Hi, everyone. Welcome back to RPS at Home for 8th grade physical science, week 5. We are on the second day, kind of part 2 of our lessons for this week. So if you're following along day by day, this should be Wednesday, May 6th. So today we are going to do a little bit more explanation about magnets, electromagnetic induction, and the two major applications of that concept, which are motors and generators. So if you did not already complete the lesson from Monday, May 4th, please go back and complete that one before we proceed. It's important that you get some experience with what I'm talking about before I actually start explaining it. So for starting off today, again, I want you to make sure that you all go to RPS at home by going to the rvaschools.net website and then clicking on the RPS at home button. And once you get there, please remember to navigate to middle school and then to click 8th grade. And you will be directed to the calendar. Today is Wednesday, May 6th, so you will click on Wednesday, May 6th, and you can access both the learning plan, which looks like this. We already completed all of day 1, and then day 2 is where we are today. So the first step is to open up our student workbook, which looks like this. So I'm just going to scroll up and down and show you the first page. We've got our title page. Please note that in order to work on this, you need to make a copy. So you can click File, make a copy, and then rename it to have your own. If you already did this on day 1, you can just use the same one. It should already be in your Google Drive. So now we're going to scroll down to day 2. You can see here the first thing we're going to do is a brain pop video on a concept called electromagnetic induction. Notice that there's the username and password given to you right here for the brain pop. So please, if you are having trouble, use that username, Richmond Public Schools _1, password for me to use with the exclamation point. And before we start, I want us to take a look at what I'm asking you to do. So what I'm asking you to do is to take a look at these 5 terms that are given in italics: induce, electromagnetic induction, generator, electric motor, and electromagnet. Those 5 terms come up in the brain pop video. I'm going to ask for you to write a definition for each one, and then either use it in a sentence or draw a picture. This works well if you've printed it out. If you are having trouble drawing pictures, there's actually a way to draw pictures on the computer. You can go to Insert Drawing and then click New, and it will actually open up a box that you can physically draw in. If you click on the line, you can draw in it. So I haven't done that much exploration with it, but I do know it's possible. So there are ways for you to draw in the document. And apparently mine looks pretty bad, so I'm just going to undo that. Now, let's go ahead and watch the brain pop video. I'm just going to share it with you so we can watch it together, keeping in mind that you need to use the username and password provided. And once you log in, if it's not already on electromagnetic induction, you can just search that in the top bar.
I was just getting to the best part. Dear Tim and Moby, how are electricity and magnetism related? From Inez. Just turn it off for now. Electricity and magnetism are really 2 sides of the same force, the electromagnetic force. Basically, that means that electricity can be converted to magnetism, and vice versa. The connection between the 2 forces was originally detected in 1820 by a Danish chemist named Hans Ørsted. He observed that a wire with electricity running through it would make a compass needle move, but he had no idea what this finding meant. A decade later, a British scientist named Michael Faraday built on Ørsted's work. Faraday correctly hypothesized that when an electric current runs through a wire, it creates a magnetic field around that wire. This discovery led Faraday to believe that the opposite might be true. A magnetic field could create or induce an electric current in a wire. To prove it, he moved a magnet through a coil of wire. Sure enough, an electric current was produced. He also found that the direction of the current changes depending on which way the magnet is moving. And the faster the magnet moves through the coil, the stronger the induced current. Meanwhile, the current running through the wire creates a magnetic field. The ability of magnets to create an electric current and of electric currents to create magnetic fields is called electromagnetic induction. The discovery of this relationship is considered one of the most important scientific developments in history. Electromagnetic induction is responsible for the widespread use of electricity in our world today. Generators, machines that convert movement into electricity, use moving magnets to create a current. Electric motors do the opposite, converting electricity into mechanical motion. And transformers use induction to convert the strength of an electric current. That's how the high voltage current from the power station is converted into the lower voltage current that your house uses. Last but not least, just about every electronic technology, from doorbells to airplanes, uses electromagnets, magnets created by electricity. It'd be pretty hard to imagine a world where we didn't use electromagnetic induction. Uh-oh. Dad's gonna be really mad if that's still there when he gets home.
And that was it for the brain pop. So when you go back to your workbook, there are spaces for you to do the definition and then use the word in a sentence or draw a picture. It's also okay if you want to use some other resources to try to figure out the answers to these questions. If you're having trouble understanding it the way that the brain pop explained it, you can, research other ways. And I'm also going to give you some of these definitions in our Pear Deck. So after you've taken some time to do that, you can then log on to the Pear Deck on electromagnetism. To do that, there's two ways. Number one is to visit joinpd.com and type in the code MAHUW, or you can click on the second link, and they'll both get you to the same place. I'm going to do the first option, so I'll go to joinpd.com and type in the code MAHUW. And when I do that and click enter, it should put me into a session that is all about electromagnetism. It always asks you how you are feeling today. And then we will start. So here's my title slide. You can use the left and right arrows on the bottom left to navigate. So I'm going to keep moving forward. The first thing that I ask you to do is to draw or type two things that you already know about the topic for today. And remember, the topic for today is electromagnetism. You have the option to draw, so you can do something like this. You could draw a magnet if you want to, or you can type in text. So when you type in text, you just click anywhere, and then you can type directly. It's up to you which way you prefer to do. Then when you're ready, you move on to the next slide. And I've got the first question for you, which is, well, what is magnetism? You all might have an idea about what a refrigerator magnet looks like, or even one of those horseshoe magnets, but you might not know exactly what magnetism is. So here's the answer to that question. And then in your student workbook, there are some notes essentially for you to take. I have highlighted the blanks. These are the words that you need to type or fill in yourself. So the question is always given on the left. The answer is given on the right. You've got a series of questions here to answer. The first one is, what is magnetism? And then we go into, how do magnets behave? What does a magnetic field look like? Or is it invisible? Can we even see it? I ask you to draw a picture of the Earth's magnetic field and see if you can observe what different magnetic fields look like. Are there any similarities between them? What shape do they have? And then we move on to the two types of magnets. How are electricity and magnetism related? And then a little bit of discussion about how generators and motors work. So to do each of these, you're just going to move through the slides. The top has a question, and in the body there is an answer. You can work through this at your own pace. There are some questions embedded here in the slides and some photographs. You also will come around slide 6 or slide 5 or so, you will get a PhET simulation that's called Charges and Fields. The directions say try adding positive and negative charges to the simulation until you get something that looks like the magnetic fields on the previous slide. Just to show you the functionality of this, to make this work, you need to click and drag charges somewhere out into the space. It doesn't really matter. You can do more than one. You can put them together, or you can make them separate. And I want to see if you can make the arrows line up in a way that looked kind of like the magnetic field that you saw on the previous slide. When you're done with that, you can move forward, and there's some more information about, in this case, the two types of magnets. There is a video embedded that I would like you to watch about how electricity and magnetism are related. And then this is a revisiting the same simulation that we did on day one, Faraday's law. I just have one question for you to answer about this, just some continued exploration about what happens when you move the magnet around, particularly what happens when you move the magnet into the coil of wire. There are a couple more slides about how generators work and how motors work. There's also a video here so you can watch what a generator looks like actually in action, and same thing with a motor. Once you are done with all of that and you've answered the questions that are on the right side, I would like you to summarize. So write 2 to 3 sentences and or draw some pictures that summarize everything that you've learned today, particularly if it was new knowledge. I think most of you knew that magnets cause things to stick together. There's some force of attraction there. So try to focus on summarizing things that you learned today about magnets and electricity that are new. And lastly, kind of as a bonus, I did include some applications of electromagnetism in our pair deck. So some really interesting technologies that use electromagnetism are maglev trains, or magnetic levitation trains. They almost like float on the tracks, and so they can go at very high speeds. Roller coaster brakes. Many roller coasters use electromagnets to stop the car from moving. Superconducting magnets. So, what is the world's most powerful magnet? How strong is it? Some of you might have seen giant junkyard electromagnets, the ones that can pick up, whole cars or big pieces of cars. Wind turbines and doorbells. So those are all just interesting things that use electromagnets. These are all links. So let's say I want to learn about the giant junkyard electromagnet. You can click on the link and it will take you to a reading passage that will explain a little bit more about how those things work. So if you'd like, just choose one. Maybe you can choose more than one if you're really interested, and just research and ask some questions about how these different technologies work. That is it for today. We will see you back on Friday. On Friday, we will do a little bit more like independent practice with this stuff. So we've got a couple of quizzes, games for you to do. And I would love to also see what you guys come up with for the how this stuff works section. So with that, have a great day. We'll see you Friday.